The last problem of the Chapter 7 practice test, we have a charcoal from a tree killed in the volcanic eruption that formed in a crater is measured for carbon-14, and we know that the carbon-14 half-life is 5,700 years. So that right there is enough for me to answer a lot of the question without even reading it. But part A does say to find a mathematical model. So the mathematical model for any half-life decay is the same as the mathematical model for any exponential decay. Okay, so the exponential model, P, is equal to A e to the kt. Now, since this is decay, I'm going to expect the variable k, the parameter here, I expect that to be a negative number. So the half-life is 5,700. That means if I substitute 5,700, P of 5,700, that's going to give me 1/2 of the initial amount. And that's going to be equal to A e to the 5,700 k. And we can just solve this. The a's cancel out, and I get a 0.5 equals e to the 5,700 k. Natural log on both sides. And then divide both sides by 5,700. So k is equal to the natural log of 0.5 on 5,700. And let's get a number for that. We get a 0.00011216. And with a special note, you have to keep all of those digits in your calculator because we're dealing with exponential growth. And since k appears in the power, little changes to k, really small changes to k, can mean drastic results in our results, or drastic changes in our results. So this gives me the model, and I probably shouldn't do it in red. This gives me the model PT equals A e to the negative, sorry, I forgot the negative here, negative 0.00011216 t. So there's my model. B, if the volcanic eruption happened 20,000 years ago, what proportion of carbon-14 is left in the tree? So what proportion, let's see, P at 20,000 years is equal to the initial amount, A, multiplied by E to the negative 0.0001216 multiplied by 20,000. So proportion is equal to, and let's multiply that out with our calculator. We get a 0.08785. And this says that this is a proportion of the original amount A that's left. So 0.08785 of the original C14 is left. And if you wanted to turn that as a percent, that's probably an easier way of looking at that. That's 8.785%. So 8.785% of the original amount of carbon-14 is left in a tree. And finally, for letter C, a nearby tree that died in the same eruption has 0.002 grams of carbon-14. How many grams of carbon-14 did this tree contain prior to the eruption? So now this is kind of the same problem, but a little bit backwards. Now we don't know the proportion or the population or the amount of carbon-14, but, the other way around. We know how much carbon-14 is left, 0.002, but we don't know how much we started with. 0.0001216 times 20,000. Okay. So we already know what some of these numbers are. We know that this over here is 0.08785. So 0.002 equals 0.08785A. So that tells me, if I do my division, that the original amount of carbon-14 left, or that we had, was 0.0227. So not a whole lot more carbon-14, but I guess maybe a lot more if we're dealing with these minute amounts. So again, we're going to write, since we have context in this, we're going to write a summary. When that tree died in the volcanic eruption, it contained 0.02276 grams of carbon-14. So that's it, everyone. This is our last question in our Chapter 7 practice test. Good luck to you.